Okay, we're going to talk about 3.3 function notation. And notice on these function notation, y equals 4x plus 1 is the same thing as f of x equals 4x plus 1. Okay, y and f of x are interchangeable. Now, if I start, the benefit of function notation, it allows me to show my input. Okay, and when I show my input, if I take, for instance, and put f of negative 2, that means everywhere where I saw an x in this rule here, and I'm going to call it a rule because it tells me what I'm doing to my input, I'm multiplying that input by negative or by 4, and then I'm adding 1. So 4 times negative 2 plus 1, that gives me negative 8 plus 1, also known as negative 7. So when I have an input of negative 2, that's what that says, my output is negative 7, which actually gives me a coordinate. And I'm going to put an xy table over here, x, and actually we'll call it not y but f of x. Okay, and I'm going to put my input was negative 2, my output was negative 7. So it easily lets me show what my input and my output is. So if I take and I do that same thing, but now I do an input of negative 1. So I'll have f of negative 1 is equal to 4 times negative 1 plus 1. And that is actually negative 4 plus 1, or negative 3. So f of negative 1 equals negative 3. Notice I'm not doing any math over here. This does not mean f times negative 1. That's just its name. It's saying when I input negative 1, I get an output of negative 3. Okay, so when I input 0, f of 0, I am going to get an output of 4 times 0 plus 1, or 0 plus 1, which is 1. So f of 0 is equal to 1. My input is 0, my output is 1. When I put an input of 1, that's 4 times 1. Notice it gets really monotonous because we keep doing really almost the same thing other than the input is changing. So when my input is 1, my output is 5. So input 1, output 5. And then last one will go an input of 2, f of 2 is equal to 4 times. Now we put a 2 where that x was. So notice I keep putting parentheses where x was. We always input inside parentheses. So 8 plus 1, which is 9. So f of 2 equals 9. Input 2, output 9. That gives me ordered pairs. It gives me 1, 2, 5 ordered pairs. The ordered pair negative 2, negative 7. The ordered pair negative 1, negative 3. The ordered pair 0, 1. The ordered pair 1, 5. The ordered pair 2, 9. And those ordered pairs are coordinates on my graph. And so I can take these coordinates now, those 5 coordinates, and plot them. Negative 2, 7. Or negative 2, negative 7, excuse me. And negative 1, negative 3. And 0, 1. And 1, 5. And 2, 9. And there we've got it. Whoops, didn't mean to do that. Okay, and then connecting those points, we end up with a line. And that line has now a name of f. Why do we call it f? Because it's f of x. If we said g of x, we'd call it g. If we said k of x, we'd call it k. And there's our function. All right. So f of x and y interchangeable there. All right. The other thing we can do is we can take and see something that looks like this. And it says find the value of x so that the function has the given value. Well, this says our function equals 18. So m of x equals 18. Notice it does not say m of 18. Okay? Those are not the same. Notice back here we always had f of something. We had a number inside the parentheses, and that meant that we needed to put that in for x. Well, now we're saying the number's on the outside. It's saying m of x equals 18. So wherever you see m of x in your function over here, you're going to put in 18. Notice the semicolon means that these are separated. Here's your actual function. here's what they want you to do to that function. So really, m of x equals negative 2x plus 4. This says put 18 in where m of x was. So I'm going to put an 18 where m of x. This whole thing gets replaced with that 18. And that does not affect the x. So essentially what they're doing is they're giving you the output. And they're saying what input gives you an output of 18. So if I have an output of 18, what would I had to have put in for x to get that output? Okay, so what I can do now is I can just solve this equation. I'll subtract 4 from each side. I get negative 2x is equal to 14. And then I could divide by negative 2. And I get x is negative 7. So the input I would have to get an output of 18 is negative 7. So x would equal negative 7. So that's what they're asking you to do. To make a connection so you might understand a little better, this says that if I had an input of negative 7, I would get an output of 18. That's really what you just found. So it's almost doing the opposite of what you were doing on this page. Okay? Here you were given an input and you found an output. Here you're given output and you found the input. Okay. So if we go over here and look at this one, P of x. P of x is 15, so that means I'm going to put 15 in for P of x. So this replaces that, or 15 replaces the P of x. That is equal to 3 over 2x minus 3. Now I know that some people get freaked out about the fractions. Don't get too freaked out. Okay, so what we're going to do is we're going to solve. We're going to go ahead and move that 3 first. So we'll add 3, 0, and 18. And then you get 3 halves x. Now if fractions really freak you out, you could just multiply anytime, forever. If you ever have a fraction you want to get rid of it, just multiply by the common denominator. And in this case, you only have a single denominator other than the one under the 18, which doesn't matter here. But so if I were to multiply everything by 2, that means this side by 2 and this side by 2. Well, notice when I multiply this side by 2, it says I have 3 halves. And I'm going to double it. Well, really what happens is those two 2's cancel. I'm left with 3x. And that equals 2 times 18, because whatever I do one side, I have to do to the other. That gives me 36. And then I can divide by 3. We get x is 36 over 3, or also known as 12. Now, I do have some of you that maybe that doesn't matter to you, the fraction. You're no worries. So if you want to do it a different way, let's start from this step here. You could have said, if I had 18 equals 3 halves x, you could have just multiplied by the reciprocal. That's doing 2 steps at once. The reciprocal is the fraction. You flip it there. So flip the fraction over. And what happens there, if I multiply by the reciprocal on both sides, notice these 2 things cancel and these cancel. So I'd be left with just x. And here I have 2 times 18 divided by 3. A fraction is just multiplying by the top and dividing by the bottom, or dividing by the bottom and then multiplying by the top. 18 divided by 3 times 2. Either way, 2 times 18 is 36 divided by 3 is 12. Or 18 divided by 3 is 6 times 2 is 12. Either way, you get the same answer. And it doesn't matter which one you do. Multiplying by the reciprocal is a little faster. But. All right. Okay, well now let's look at some application of this. Let n of h be the number of cars at an intersection near school h hours after 5 a.m. That is saying for every hour after 5 a.m., h is going to change. It's going to go increase a number. So for instance, at 5 a.m., n of 0 would be 0 hours after 5 a.m. So n of 0 means that it's 5 a.m. That means n of 1 would be 1 hour after 5 a.m. or 6 a.m. N of 2 would be 2 hours after 5 a.m. or 7 a.m. N of 3 would be 3 hours after 5 a.m. or 8 a.m. N of 4 means 4 hours after 5 a.m., which is 9 a.m. What is the meaning of n of 2 is greater than n of 7? Well, n of 2, let's know what that means first. N of 2 means 7 a.m. N of 7 means 5 hours or 7 hours after 5 a.m. So n of 7 is noon. Okay? And so this says 7 a.m. is greater than noon. Well, it doesn't make much sense. N of h, number of cars at the intersection near a school. Okay, the number of cars at, oops, let me write that differently here. Or at least, I'll write the same thing, but kind of write it out. The number of cars at the intersection at 7 a.m. is greater than the number of cars at the intersection at noon. All right, that's what it's saying. Okay, well, that's it. Good lucky on functions. Remember, first 3 letters of functions are F-U-N. Fun stuff. Woohoo!